In this video I'm gonna talk about Ohm's law, which is the most simple law which you absolutely need to know if you want to analyze circuits. So once you know it, then you can explore everything else. So this is fundamental, so as I decided to make one playlist for circuit analysis, I decided to start it with Ohm's law. So it's basically a very simple formula. R equals 2V divided by I, where R is for resistance and it is denoted with this sign. It's measured in ohms. So here we have, this is resistor, and here we have 2 ohms, so this is 2 ohm resistor, and V is a voltage, which we don't have voltage source here, but it looks like this. This is a voltage source. Basically it has plus sign and a minus sign, and it is expected that the current goes from the plus sign, although the current, it is the convention that current goes from the positive polarity to negative, but as it is a source, it is giving out the energy or current, so it goes from plus. But it sometimes happens that the voltage source is an absorber. So this is voltage, and it is measured in voltages, so we just say V when we want to express it, just like I have here, 4 volts. And the last one for this law is amperes, which stands for current. So I denotes current, so I is current, and it is denoted with amperes. So this stands for ampere, and whenever you want to specify how much current is going through somewhere, you say amperes. So let's have a look at our circuit. So this is a very simple circuit, and we have a independent current source and a simple resistor. So what we don't know in this circuit is voltage through this resistor. So from our formula we can say that V equals IR. Basically it's by multiplying both sides by I. We also, if you don't want to memorize 3 kinds of separations, you can just, for example, we have 2 amperes, right? So let's start with resistance. So I have 2 equals voltage, which we don't know, divided by resistance, no, amperes, I amperes. We have 2 amperes, so we type in here 2, and from here we conclude that if we multiply both sides by 2, so if we make something like this, we will get that 4 equals to V. So we have voltage of 4. So voltage across this resistor is 4. Now let's have a look at circuit with voltage source. So what we don't know here is the current passing through this resistor. And again, with Ohm's law, we can easily determine it. This is our Ohm's law's expression formula, and we just plug in stuff we know. 2 equals, wait a second, I forgot to V, because it is voltage. And as I said, it is denoted like this, so we do that. So from here we just substitute what we know, and what we know are voltages and resistance. So 2 for resistance equals to V. We know V in this case, we have 4V, 4 voltage, and 4 volts, which is divided by I, which we don't know and we need to find its current. So we can do this by multiplying both sides by I. We will get 2I equals 4, and from here if we solve for I, which means dividing by 2 both sides, equals 4 divided by 2, which means that we have current 2 amperes. And this is basically the same number we got in our previous circuit. And as you can see, we have 2 amperes here, hence we got 4 voltages, 4 volts, and as we had 4 volts here, we got 2 amperes. So these circuits are equivalent, but they are made with different sources, but they are still kind of equivalent, because we have same voltage across and same current across. And that explains Ohm's law. Thanks for watching.